So my talk is about extending Remix with Rust. And to start you off in this journey, I kind of have to mention one of my formative JS career paths at one of the first companies I worked at. I was supposed to onboard users. And we had a process that was manual, or at least semi-manual, and we needed to automate it. And it involved taking a lot of JSON, a lot of data, doing a bunch of computations, throwing it in all the databases, doing all the work that you have to do for that. And it wasn't very fast. And being a Create React app and being written in JavaScript, I didn't really have too many options too many levers to pull. If you've been to the workshop yesterday, you've been here earlier today, you can kind of imagine what I ended up doing. Spinners, optimistic UI, skeletons, all that stuff is great. But at some point, the user is going to stop paying attention to the thing and just eat you. Or stop using your app in this case. And that's pretty much the feedback that I got. I must go faster. So I'd like to expand a little bit on the idea of progressive enhancement, that maybe sometimes JavaScript is not enough and that you should consider writing it in Rust or a different language that can do those tasks faster. Why would you want to write it in Rust? Well, it's a very fast language. It's not C, but it's as fast as C. It offers memory and thread safety, which is great if you ever run into race conditions, because I hate those. And it's very productive. And developers have loved it. Every year, the Stack Overflow developer survey, it wins most loved language. Last 7 years running. So they're doing something right over there. Companies also tend to love it if you pay attention to that stuff. Pretty much everybody is talking about either rewriting or writing it in Rust, which is really neat, considering, gives me some job security. But I'm here to talk about Rust with Remix. So if you want to use Rust in your Remix app, it's actually really easy. You can either compile it into WebAssembly and then run it on either the browser or the server, or you can compile it into a native module that gets called from Node exclusively on the server. That's what the process looks like generally. Rust gets compiled into something else, and then it gets processed through a tool that auto-generates the JS wrappers you need to use it easily. It's really made my life easy for the most part. Once we got it into Remix, which was not as easy. This is the process that you would use if you were going to install something like that. It's pretty straightforward. Install Rust. Install the tool that generates the JS, create a new project, add some code, build it, ship it, right? This is what the Rust would look like, a very simple function. It's pretty much pure Rust, and then you just decorate it with a macro that will auto-generate all of the JS stuff for you. This is the WASM version. The native version pretty much functions exactly the same way. It just has a different macro that you have to call. So if you go for one of these and you decide you want to do a different one, it's really easy to change. And here's how you would use it on Remix. On the server, at least, it actually gets created as a Node module. So you can import it exactly like you would any other Node module. And use it in your actions and loaders and pass in and out JavaScript data and all the fun stuff that entails. The browser is a little bit trickier, though, because the browser doesn't support loading WASM, and you kind of have to have WASM in memory, WebAssembly in memory to use it. So you have to use a use effect. Not a huge fan of use effect, but, I haven't written one since I started using Remix. It's really nice, until his workshop, and then I had to write a bunch of them. WASM's great for a bunch of different things. Games, there's a huge gaming community that writes their stuff in Rust, compiles it to WASM, and loads it in your pages. You can take the things that are hard for you and move them from your server to their computer and save all of your money, which is kind of fun. And you can do all sorts of intensive things. The 3D talk earlier doesn't use Rust, but there's a similar Rust way to do that, so it's pretty neat. Lots of possibilities there. It's not actually native performance. It's close to native performance, but it runs in a virtual machine and it has some restrictions. So if you do need a little bit more native performance, you can write it in a native module, which will only run on the server, but essentially runs on your desktop or your server. So you have full access to everything that you could ever want, and it's slightly faster. So I've been saying that it's faster a bunch. Let's throw out some actual numbers to kind of support that. I took a 20 megabyte JS or an image file, and I converted that into bytes and stored it in a buffer. And then I wanted to hash it with SHA-256. You know, if maybe you want to keep track of the file changes and you want to store that in your database, right? And then I ran it one time each in a remix loader, and I timed it each time, and I went to see how long it would take, right? So, pretty substantial change. This is one file, right, with no other load, no latency, anything like that. And already, native is 270% faster than a pure JS implementation was. And WASM's 234. So you can get a lot of benefits out of that. There are sample projects and PRs that you can check if you're interested in looking more at it. I'd like to thank the maintainers and the Remix team for inviting me here. And I can't wait to see what you guys come up with. If you have any questions, feel free to reach out on Twitter or whatever resource you have. Thank you.